Hey y'all, Mr. Riley here with our first two topics in the next unit. Unit 7, which is algebraic expressions. And we're going to start by looking at the distributive property, something that you have been doing for a couple of years. And then we will, of course, take it to one more step here in 7th grade, and actually some 8th grade topics here today as well. So expressions, right? Expressions are numbers or variables and operations, no equal sign, okay? And two expressions are equivalent when they have the same value. So if we are talking just with numbers, two expressions here like 5 times parentheses 6 plus 7 and 5 times 6 plus 5 times 7, these are equivalent expressions because they would be equal to the same number if you work these out, which we'll do here in a second. Okay, so these two examples here show you how the distributive property relates to equivalent expressions. If you have a number and then a sum or difference, right, an addition or subtraction in parentheses, you can multiply that number in the front by both of the numbers on the inside, okay, and get two separate products, but then these are going to be equivalent fractions. Okay, so that's what we're going to look at first. Now, you've done the distributive property in previous grades mostly with all numbers here. So let's take a look at this expression, 3 times the parentheses 4 plus 6. The sum 4 plus 6. Okay, so you can do this problem because it's all numbers. You can do it using the order of operations, which would tell you to do inside the parentheses first and get 3 times 10, and then multiply 3 times 10, which is 30. The other option here is to use the distributive property. So that means to do 3 times 4 and then 3 times 6 and add those two things together. So 3 times 4 plus 3 times 6, that's 12 plus 18, which is also 30. Which one of these is the easier method? I would say it's probably the order of operations, but okay, if you wanted to, you can look at this math antics video. Just search math antics, distributive property in arithmetic, and it'll do a couple of examples of this, but let's take a look at some examples. Now, the distributive property is very helpful in multiplying, especially one-digit numbers times two-digit numbers or three-digit numbers, because you break the larger number into its parts, into its tens and its ones, and that's how you do problems like this in your head. Okay, so very quickly here, a little exercise. 4 times 26, that's 4 times 20 plus 4 times 6, which is 80 plus 24, or 104. And you should be able to do this in your head without writing anything down. 5 times 132. 5 times 100 plus 5 times 30 plus 5 times 2 is 500 plus 150 plus 10. That's 660. 8 times 54, 400 plus 32. Done. 9 times 41, 360 plus 9. 2 times 734. Now, these numbers are a little bigger. 2 times 700, 1,400. 2 times 30 is 60, and 2 times 4 is 8. 1,468. So this is how you do problems like this without a calculator, using the distributive property. Now, that is not what we're going to look at here mostly here in this class. We are going to look at algebraic expressions, but let me go back to the book here, to page 292, and just look at the examples that they do, like the ones that we just did. 5 times 12 plus 4. 5 times 12 plus 5 times 4, 60 plus 20 is 80. If the number out directly next to the parentheses is in the after the parentheses, that's okay. It's the same exact thing. You still can distribute, okay? And here would be 8.2 times 20 minus 8.2 times 3. That's 164 minus 24.6, or 139.4. Got it? 1A. 6 plus 3 times 4 is 24 plus 12, which is 36. 3/4 times 9 minus 3/4 times 2. Now it looks like the fractions are not going to go away here, so you will kind of keep these as fractions with a common denominator. 27/4 minus 6/4 is 21/4, or 5 1/4. This is also lets you do, as it's talking about here, distributive property allows you to find products mentally. We've already gone over those examples. And a lot of times you can use it for money things where you have prices that are very close to $1. Okay, like in this example, where tickets are $8.99. What's the total cost for 20 students? So the easy way to do this is to say, well, it's 20 times 9, right, which is 180. And then each $9 is minus 1, right? $8.99 is 9 minus 1. So you're going to subtract off 20 cents at the end, get $179.80. Do you need to be able to do this one in your head? I mean, it's probably fine to just say 20 times 9, and that's close enough for this type of problem. So we won't spend too much time on these. But there is an IXL topic, 9BA, if you'd like to practice these distributive property real in using numbers like this. But it's not really what we're focusing on here in this topic. The bigger focus for us are algebraic expressions using the distributive property. So an algebraic expression has variables in it, not just numbers. We can model algebraic expressions. I don't know that we've done this previously. Okay, using these are called algebra tiles. We have like these long sticks to represent your variables, x in green, or if it is on the red side, negative x, and then little squares to represent numbers. So this model here is x plus 4 on each row here. So it's 2x plus 4s, right, which is what this shows here. Well, that's the same as if you kind of went downwards, 2x's plus 8. So 2x plus 8 is the same as 2 times parentheses x plus 4. And that's what it mentions down here, that these are equivalent expressions. Okay, these are equivalent algebraic expressions because they still have the variable in them, but you can't simplify this any further. You cannot combine 2x's plus 8 because you don't know what x is, what the value is that x is using. So distributive property means to take a multiplication outside the parentheses and multiply it by everything inside the parentheses. Okay. The equivalent in the real world is distributing is passing something out or giving it out to a bunch of people. All right, so I affectionately call the distributive property the rainbow method, and that's because a way to think about it is to sort of draw these rainbow arcs to show the different multiplications in the problem. So you have a number in the front and then a sum inside parentheses, okay, and these can be any numbers. And so this is the same as distributing and doing A times B plus A times C, okay, which we have done several examples of this now. So in algebraic expressions, it looks like this. So 2 times x plus 2 times 3y, that's 2 times x plus 2 times 3y. Sorry, I didn't read that the right way originally. 2 times 3y is 6y. And I can't combine these together because they are not alike. They don't have the same variable. We'll talk more about that in a minute. And so that's my final answer, 2x plus 6y. It is a simplified expression. Okay, simplified expressions do not have any parentheses in them. Be careful. Sometimes you have negative numbers now involved in this. So negative 4 times the quantity 5 plus 2y is the same as negative 4 times 5. First half of the rainbow plus negative 4 times 2y. That's negative 20 plus negative 8y. And I could rewrite this because plus negative 8y, that's the same as just minus 8y. You do not have to write this step here, the individual multiplications, okay? Most of you in this class don't need to do that and can just do this multiplication in your head and write the answer, okay? All right, last example here, negative 3 times 2x minus 7. Now, it's good practice for many of you, anytime you have subtractions here, to change this subtraction to plus a negative, so that when you do your multiplications, it's easier to see that you're going to use the multiplication rules for positive and negative numbers. So this one is negative 3 times 2x, first half of the rainbow, and negative 3 times negative 7. Negative times positive is negative, so that's negative 6x. And negative 3 times negative 7 is positive 21. All right, so these are some examples of using the distributive property to simplify an algebraic expression. The book gives a couple examples, very similar to what we just did. 4 times x plus 5 is 4x plus 20. And y plus 10 times 6 is 6y plus 60. All right, so a couple of got-its for you to do. 2.4 times a plus 5 and b plus 6 times 3. 3a, 2.4 times a plus 2.4 times 5. And to do 2.4 times 5, you got to do that with the distributive property also. It's 5 times 2 plus 5 times 0.4. That will be 10 plus 2. So it's 2.4a plus 12. That is my final answer. Letter B, 3b plus 18. All right, so that's the distributive property, the first part of the lesson here, the first topic in Unit 7. Whoops, there's more I forgot. More of the same examples, but now they're thrown in a bunch of minus signs. Okay, so now the negative signs come in here, makes these a little more challenging. M minus 4, we're going to rewrite as m plus negative 4. Same change. Right? It's just good practice in these problems to change subtractions to plus a negative. Okay, you don't really have to rewrite it like that. You can do this if you want and just do plus negative like that. So that's 3 times m plus 3 times negative 4, which is negative 12. And then rewrite plus negative is the same as minus, so 3m minus 12. And then here, when you have a negative number multiplied by a subtraction, again, safer to change this to plus negative 7, so that then you do your rainbow of negative 9.5 times n and negative 9.5 times negative 7, which is going to be 63 plus 3.5, right? 7 times 9 plus 7 times 0.5, and it's negative times negative, so that means it's positive 66.5, and there's your final answer for that one. 2 for you to do. 4a, 2/3 times d minus 3. 2/3 times d, that's 2/3 d. 2/3 times negative 3 is negative 2, because the 3 on the top here, 3 And the 3 on the bottom will cancel out if you cross reduce, and you get 2/3 D minus 2. For B, negative 7E plus 28. Negative 7 times negative 4 is plus 28. The most common mistake in these problems is to forget the second half of the rainbow, which you will see as these get a little more complicated. All right, so that's the first lesson, distributive property. I'm not really sure why they do the distributive property before this second lesson about algebraic expressions. It seems a little bit backwards, but that's okay because we're doing them all together. So we move over to page 299 now, the second topic in this chapter. So when you have an expression and it is separated by additions and subtractions, okay, each part that is separated by the additions and subtractions is called a term. A term is a number or a letter, variable, or a multiplication or division of numbers and variables. That is a term. They are separated by additions and subtractions. Okay, so there are 4 terms in this expression: 3x, 7x, and 2. Reminder here, this is a little vocabulary refresher, this page. The number that a variable is multiplied by is called the coefficient. Okay, and sometimes there is just a variable with no number in front, and that means that there is really a 1 there. I'll call that the invisible 1. We'll talk more about that later. And so this expression has 2 x terms and 2 terms that do not have a variable. Those are called constant terms or just constants. Okay, a constant is a number that's always the same. Variables can change. So if there are no letters in your term, no variables in the term, it is a constant term. Now, to simplify expressions, okay, first off, it tells you in this chapter, we're only going to work with terms with an exponent of 1. I will probably throw in some terms with exponents not 1. Talk about down here, okay? So that's why they say in this case, like terms are terms that contain the same variables. Okay, so if the letters are the same, then the terms are like terms, and they can actually be combined. Okay, so 2n and 5n are like terms, 6xy and 4xy are like terms. I don't know why the book doesn't talk about exponents here, but the other thing that has to be true, not only do the letters have to be the same, but the letters have to have the same exponents. So 2x squared and 3x are not like terms because their exponents don't match. You will see them in my examples because I'm using 8th grade examples in my lesson here. So that's why I bring this up as well, even though the book doesn't talk about it. Like terms have to have the same exact variables and the same exact exponents on the variables, or no variables at all. Constants, if you have more than 1, those are like terms also. So you get the vocabulary here. You should be able to identify the like terms in these expressions and also say how many terms there are. So letter A here, there are 3 terms, and the like terms are 3x and 4x because they have the same variable. Letter B, 4 terms. 5x and 7x are alike, and 3 and 4 are alike, like terms. All right, so they got it here. What are the like terms in this expression? Negative 4x and 2x are like terms, and so are 2y and 3y. So this is not very difficult. And you'll have an IXL topic to do this kind of work, which should take you all of about 5 minutes. Subtractions in an expression can always be written rewritten as adding the opposite, and that's a good idea to do that. Okay, it really keeps you out of trouble, especially if you're not so great with positive and negative numbers. But you can just forget that these things are actually negatives if you don't change your subtractions to plus the opposite. So anytime you have a subtraction in a long expression like this, it is good practice to change it to plus and negative. You do not have to write the parentheses in here. You could just write plus negative 2y. Okay. They also threw in an invisible 1 in this expression, right? This plus x, there's an invisible 1 there that you could add in, or you could just remember that it's there. All right, so what are the terms in this expression? And the terms have to be separated by additions. So 6x is a term, negative 2y is a term, not 2y, negative 2y because it's of the subtraction. X and negative 5. Those are the four terms. 6x, negative 2y, x, and negative 5. Like terms, 6x and x are like terms. The only ones. The coefficients in this problem, the coefficients are the numbers that variables are multiplied by. That would be 6, negative 2, and invisible 1, right? 6, negative 2, and 1 are the coefficients. And the constant in this expression is negative 5. Negative 5, no variable. And it's negative because this is actually plus negative 5. All right, so your turn to do that down here. What are the terms? What are the like terms? What are the coefficients? And what are the constants? The terms are 3n, 5m, negative 6m, and 2. The coefficients, 3, 5, and negative 6. Negative 6 because there's a subtraction here on this 6m. Whoops, I missed like terms. Like terms, 5m and negative 6m. And lastly, constants, 2. Constant is the term with no variable. Okay, so that's vocabulary. Identify terms, identify coefficients. Can you identify like terms? Do you know what the constant terms are? And we're going to use this vocabulary to simplify expressions by combining like terms. Okay, so an algebraic expression is in its simplest form. It is simplified if there are no like terms and no parentheses. Okay, so if you use the distributive property and then you combine like terms, you are simplifying the expression. So sometimes no parentheses here, you just are going to combine the like terms. And you combine like terms by adding their coefficients. So 4x plus 6 plus 2x. The like terms are 4x and 2x. Now, the book will show you in this example that you can use the commutative property, right, changing the order around because it's all addition. And 4x and 2x, you can add them together to get 6x. Never, ever, ever, never would I expect you to write either of these steps. Okay, it's just showing you what you should be doing in your head, which is adding the terms that are like terms. They have the same variable. You add their exponents. So the work you show for this problem is answer. That's it. 6x plus 6. And again, you can't combine these together, the 6x and the 6, because they are not like terms. 6x has an x in it, and the other term is a constant, so you cannot combine them. All right, so here's my notes here on simplifying expressions and combining like terms. And you might notice that I threw in an exponent one here. All right, so if you have long expressions like this, which you might see at some point, it is helpful to kind of mark off each of the like terms as you get to them. So I'll put dots underneath each one. Okay, so first we'll identify no subtractions in this first one. So 5x, okay, what other terms are like with 5x? Needs just an x. Oh, there's 1, 2x. And 7y, no, and no, and no, and no. And that's it. No other x terms. Okay, how about y terms? I'll put 2 dots under those. Some people put different shapes around these. That's another way to go. 3y, let's see what's like with 3y. 7y squared, same letter, but different exponent. So it is not like with 3y. 9, no. 2y, okay? And then we'll go to 7y squared. We'll give that 3 dots. Any like terms with that? Nope, that's the only y squared term in this expression. And finally, the constant terms. Put 4 dots under that, 9 and 12. Okay, so once you have identified all the like terms, then you can add the coefficients of the like terms to simplify the expression. So 5x plus 2x gives me 7x's. 3y's plus 2y's is 5y's. 7y squared. And lastly, 9 plus 12 is 21. This one's super simple because it is all additions. If you put subtractions in there, the thing you should do is change them all to additions. So all of these subtractions, I'm going to change to plus and put a minus sign on the coefficient. Plus and put a minus sign on the coefficient. Plus and put a minus sign on the coefficient, which here is an invisible 1, which you can also draw those in if you want. Kind of have them standing by here. Right? There's an invisible 1 there. Same thing over here with y. There's an invisible 1. It's very common to forget that when you are combining like terms. I'm forgetting that invisible 1. And we got one more subtraction here, plus -1. Okay, now we can identify the like terms. So I'll go with shapes this time. So we'll circle 4, and this is constant terms. So are there any other constant terms? No. There's one. And there's another one. Okay, so those are constant terms. Now we have x terms. We'll put squares around those. So there's a -2x. And another -2x. -5x squared. The exponent means it is not like with these. That is not an x term. That's an x squared term. We got this -1x. And that's it. And then y terms. So there's a plus 1y and plus 4y. And then there's the last one there, 5x squared all by itself. There are no other terms left. Sounds by itself. All right, so now we're going to combine the like terms to simplify this expression. 4 plus 6 plus -1 is 9. -2 coefficient plus -2x's is -4x's. Plus -1x's, so that's -5x's. -5, adding all the coefficients. I got a y plus 4y, that's 5y. And finally, a -5x squared. So I can leave my answer like this for now, okay? Or you can change all these additions, adding the opposite, adding a negative to subtractions. And you can also put these in order, which we'll talk about more later, about what order they're supposed to go in. -5x squared minus 5x plus 5y plus 9. But for now, if you leave it like this, that's perfectly okay. We'll talk more about this on Tuesday. Okay, so the book goes through a couple more examples on page 300, combining like terms. Again, I would write this step, which you could just do right in the problem itself, right? Changing your subtractions to adding the opposite. And your next step should be the answer 4n plus -4, or as they say here, 4n plus minus 4. Okay, you got 5n and -n is 4n, and 2 plus -6 is -4. 6y minus 3 times x minus 2y. So now we have distributive property and then some like terms after that. A minus sign in front of the distributive property like this, very easily missed by people. You want to change this minus sign to plus -3, which they have done right here. Okay. And then also the subtraction inside the parentheses, like we talked about before, change that to plus a negative. All right, now do the distributive property. So always do the distributive property before you combine like terms. You have to do it that way. So a little rainbow action, -3 times x, -3 times -2y gives me this answer here. So this step of work, you probably should write what you get after you do the distributive property. Now you can look for like terms. There's a 6y and a 6y, and then a -3x. So the y's combined together to give me 12y. 12y plus -3x, or rewrite this plus a negative as subtraction, 12y minus 3x. All right, so let's finish off with a couple of got it's here, 3, I guess. Do these problems, simplify these expressions. Only problem letter C should have a step of intermediate work. The other ones you can actually just go right to the answer. 3a, x plus 6. Now, if you said 1x plus 6, that's okay, because you get 4x plus -3x leaves you with 1x, but you don't have to write the 1. Okay. And then the 6 is by itself because there's no other like terms, no other constant terms. All right, letter B. That's going to look like a -5m minus 1. Again, 2m and plus -7m m's gives you -5m's, and 3 plus -4 is -1. Last one, distributive, no negatives here, so that's good. Distributive property first gives me, do a little rainbow action, 4 times q, and 4 times 8p is 4q plus 32p. And the plus p over here is still there. We didn't do anything with it yet. And now, after we get rid of the parentheses, we can combine like terms to 41 plus 33p. All right, so that's the first couple of topics here. Distributive property, the rainbow, multiplying the number on the outside of the parentheses times everything inside the parentheses. And then simplifying expressions by combining like terms and identifying terms, constants, coefficients, like terms. Okay, that'll do it for now. And we will talk more about these in class in the next class.